Hello everyone. Today we will discuss about concept generation and concept selection. So we will discuss about two chapters at once. First, let's talk about concept generation. Uh, we will give you just an overview of these two chapters. So I will go quickly uh, in some slides. Okay, we have already been familiar with the concept development process, and we are now here in the generate product concept. So the outline of this chapter is about product concept, about definition, and then commonly these functions in product development, and 5 steps in the product concept generation process. So product concept is a technical description of how the product will satisfy the customer needs, and it is an approximate description of the technology, working principles, and form of the product. It is often expressed with a sketch or a 3D model, accompanied with a brief textual description. This is an example of a product concept. If we talk about common dysfunction during concept generation, there are some. First is consider only one or two alternatives. We should have more. And then fail to consider the usefulness of the concepts. Involve only one or two people in the process. Ineffectively integrate promising partial solutions, and fail to consider entire categories of solutions. So the concept generation process includes 5 steps. First, clarifying the problem, and then search externally and then internally, and then we explore systematically. Last but not least, we reflect on solutions. So here is the illustrations of those steps that we have in the concept generation process. So in the concept generation process, we have problem decomposition in clarifying the problem, and then in the external search we will deal with lead users, experts, patents, literatures, benchmarking. In the internal search, we have individual methods and group methods. In the systematic exploration, we have classification tree and combination table. We will go into deeper about that, and we can reflect on the process to make a continuous improvement. So from the diagram or illustration here, external and internal search can be done in parallel. So let's talk about clarifying the problem. So we need to understand the problem first, and we derive that from the team's product mission statement, from the customer needs, and from the product specifications. Those are the topics that we have discussed in the earlier class or sessions. And then we decompose the problem into simpler sub-problems. Divide and conquer using function diagrams, so decompose by sequence of user actions, or decompose by key customers' need. And we focus initial efforts on the critical sub-problems, like focus on critical sub-problems and give a solution to other sub-problems. We will see how later. Let's take a look at an example of Power Nailer. So it's a tool to fix a nail into something, like for example into wood. It is usually used in the rooftop. So it's about rooftop nailer works. Rooftop nailer, sorry. So we have here the mission statement that it will use nails. It will be compatible with nail magazines. Yeah, it will nail through roofing shingles into wood, and it will be handheld. Assumption that we use here: it inserts nails in rapid succession, it is lightweight. It has no nailing delays from the user's view. And the specification that we would like to have for this power nailer is that nail length range from 25 to 28 millimeters. Nailing rate is 1 nail per second, and tool mass is less than 4 kilograms. Okay, now we try to decompose the problem with a function diagram. So if we look a handheld nailer as a process in the middle here, we will have input and we will have output. In the input side, we have energy, and we have materials, which is nails, and we have signal or tool trip. And the output side will have also energy, material, and signal. So if we try to decompose the handheld nailer and try to zoom in the handheld nailer, we will have, like for example, in the energy side, a mechanism to store or accept external energy and to convert this energy into translational energy, or movement, and then apply those translational energy to nail, and the outcome will be the driven nail. In the nail part, on the other hand, we will need to have in the handheld nailer a compartment or a place to store nails and to isolate nails, and we will feed the nails and go into the applied translational energy to nail. And trip of tool, on the other hand, we have sense trip, trigger tool, and again apply translational energy to nail, and will result in the driven nail. So the next step that we will have here is to search externally. In searching externally, we can interview lead users, or we consult experts, search patents, search published literature, and benchmark related products in the market. So hints for finding related solutions: we can deal with lead users, try to take benefit from the improvement or innovation source, because lead users, we know, is the extreme users that usually they have high requirements. They are very demanding type of users. And then from benchmarking, we can take a look at the competitive products. From the experts, we can have insight about technical expertise and experienced customers as well. From the patents, we can search related inventions. And from the literature, we can take a look at technical journals and also literatures. So those are external sources for searching. We can do it in group or individually with guide for the research. And to make the research, there is a guide for that. We first need to suspend the judgment, and we need to generate a lot of ideas. We will come ideas that seem invisible initially, usually, and then we use graphic and physical media. And hints for generating concepts here is that we can make analogies, wish and wonder, user-related stimuli, set quantitative goals, and post ideas on the wall. So these are hints or guides how to make a search internally, both group and individually. Okay. So this is just an example. Maybe it's a little bit technical. You don't have to, really go into detail. But here is just options of solutions that are available that we can think of that could be the alternative solutions for our problem in developing handheld nailer. So for example, solutions to solve problem of storing and accepting energy. So please don't forget that we have in the decomposing the problem before, we have things about storing or accepting energy, and we have also applying translational energy to nail. So from the external and internal search, we might have lists like this. In storing or accepting energy, we have different ways of storing or accepting energies: self-regulating chemical reaction, for example, carbide, combusting, gunpowder, sodium azide, and so on and so forth, with steam supply line, wind, geothermal. So we have all these means or ways in storing or accepting energy. On the other hand, the solution or alternative solution to some problem of applying transfer energy to nail will have single impact here, multiple impacts. Yeah, this is the impacts, multiple impacts, and then multiple impacts with hundreds or thousands, even more multiple impacts here. Push or using twist push. So these are the ways how we apply transformational energy to nail. And then we try to explore those alternatives systematically. We need to have something called concept combination tree. We will learn about that in a minute. And we will have concept combination table. What is concept combination tree? There are some points here. We divide the possible solution into independent categories. We prune less promising branches and then identify independent approaches to the problem. Expose inappropriate emphasis on certain branches. Refine the problem composition for a particular branch. Okay, and for combination table, guide the team in selectively considering combination of fragments. So we will see from the case that we have about power later how to make the concept combination table as well. So from storing or accepting energy part, we have alternatives. We can store the energy chemically or pneumatically, or hydraulic, electrical, or nuclear. From chemical, for example, we have option of using fuel air system or explosive systems. And in the electrical storing energy ways, we can have wall outlet, battery, or fuel cell, for example. So in the electrical, if we focus on the electrical energy, we try to convert energy to transformational energy, accumulate transformational energy, and apply those transformational energy to nail, and we will have energy applied to nail. So with this systematic exploration, we try to combine some alternatives going into these three ways or three steps. Like for example, if we go back here, we have convert energy and then accumulate energy and then apply. So we will have here convert, accumulate, and apply into this column. And the converting electrical energy into transformational energy, we have different ways like rotary or linear or solenoid or railgun. And the accumulating energy will have spring or moving mass. And the applying energy to nail, we have single, multiple impact, or pushing nail. So by looking or making this table, we can think of different type of combination as we are exploring systematically the alternatives. So this will be the second alternatives, in which we use solenoid to convert electrical energy to transformational energy, and we use spring to accumulate the energy, and we use multiple impacts way to apply transformational energy to nail. In the solution concept, a solenoid compresses the spring and then releases it repeatedly in order to drive the nail with multiple impacts. So this is the illustration of how this concept could be applied. This is the other concept, or the other concept alternatives, in which we use rotary motor with transmission to convert electrical energy to translational energy, and we use also spring here to accumulate the energy, and we use single impact to apply translational energy to nail. And we will have here different type of concept that could be possible to implement this concept. In here, multiple solutions arising from the combination of a motor with transmission, a spring, and single impact. The motor winds a spring, accumulating potential energy that is then delivered to the nail in a single blow. So we have here three possible solutions. This is the other combination, but the principle is the same. We use rotary motor spring but with multiple impacts, and it will has different kind of solutions. Here is the other combination. So we can have from this combination table, we will have different type of combination with certain mechanism that we can draw here as an alternative. So here we use linear motor with moving mass as accumulating energy waves, and then we use single impact. So this is about generating concepts. If we reflect on the result, into the solution space, do we have alternative function diagrams? Do we have alternative ways to decompose the problem? Do we have additional external resources? Do we have all ideas generated and integrated? Okay, so this is about concept generation again. And next, after we generate concepts, usually we generate few or several concepts, we need to make a concept selection. So of course, this is the part of concept development process altogether. After generate product concept, we'll go on to the selecting the product concept, and the outline of this chapter will be introduction to product concept selection, commonly dysfunction in product development and product concept selection process. So the definition first. Product concept selection is a decision process in which the design team selects one or a few product concepts for further development. Challenges here is how to choose the best concept from the abstractions. Okay, how to choose the best concept, and then how to embrace all inputs, likings, and concerns from the whole team in the decision process. Remember that we work in team. And then how to make use of good attributes of otherwise weak concept designs. So even if we have weak concept designs, we might still can use some good attributes out of it. And then last but not least, the challenge will be how to document the decision process. So the concept approaches, we will have a different approach here. External decision by use of an external group of customers, clients, etc. Product champion and intuition, so by an influential member of the development team. Multi-voting, using pros and cons, where the team lists the strengths and weakness of its concept. We can use the prototype and test approach, build and test prototype for each concept and select based on the test data. And we make a decision matrix. The team rates each concept against selection criteria with varying importance or weights. In this chapter, we will focus more into the decision matrix. So two stages of the concept selection is that concept screening and concept scoring. So concept screening to quickly narrow the number of concepts and improve the concepts, and its scoring is weighs the relative importance of the selection criteria and focus on more refined comparison with respect to each criteria. Okay, so what are the steps in the concept selection process? There are 6 steps here. Prepare the matrix, rate the concepts, rank the concepts, combine and improve, and then select the best concept. Last but not least, we reflect on the process. Okay, so we have something called concept development funnel here. Usually in the red part we will have concept generation. We will have a lot of concepts here. There will be concept screening like in the purple part here, and we will have concept scoring, this blue part. So we will narrow down again the concepts by using scoring, and we will end up with concept testing. So from this alternatives of concept we have in the concept generation, we might end up to test only one concept. Remember, the goal of concept selection is not to select the best concept. The goal of the concept selection is to develop the best concept, because we might combine 2 or 3 concepts together to come up with the best concept. So remember to combine, refine the concept to develop better ones. Okay. The next example that we have here is a reusable sirens, a tool to inject for injection. So the mission statement for this particular example is the product description is reusable sirens with precision dosage control for outpatient use. The primary market is elderly people. Major features is accuracy and dose metering, and also inexpensive. So need analysis here is ease of handling. It should be ease of use, readability of dose settings, accuracy of dose metering, durability, ease of manufacture, and portability. So these are the alternatives or options of the selections. We have concept A, it's called master cylinder, concept B, rubber brake, concept C, ratchet, concept D, plung stop. So you don't have to go into the detail here, but you see that those are different options of how you might come up with an injection or sirens. And we still have more concept E, swash rings, called swash ring. Okay, concept F, lever set, is using a lever here, operating lever. And then the concept G, dial screw, we have a dial here, and then to put also the injection. So we have 7 concepts altogether from A to G, and we need to select or to come up with one best concept. So now we are coming to the concept screening principles. We focus on customer needs first of all, and then match or exceed competitors' performance along key dimensions. Improve the product's manufacturability, reduce lead time, encourage more and effective participation from the design team members, and have better documentation of the decision process, of course. So these are the principles. And the concept screening steps that we have here, we have 6 steps, more or less the same like before. That prepare a selection matrix based on the selection criteria, rate the concepts, rank the concepts, combine and improve the concepts, select one or more concepts, and reflect on the results and process. Okay, so this is the example of concept screening matrix, so speaking. We have concept variants from A to G, A, B, C, D until G. And we have selection criteria like ease of handling, ease of use, and so on and so forth, and portability. And we have here the plus and the minus. So the reference here could be like, for example, the existing product in the market, which is we put 0, and we put plus if it is better than the reference, and we put minus if it is worse than the reference, and we put 0 if it is more or less the same with the reference. So for example, the concept A here, in terms of ease of handling, ease of use, and number readability, it's almost more or less the same with the reference. So we put 0 in all these 3 criteria, but in dose metering it's better, in dose handling it's almost the same, manufacturing and portability it is plus. So we have 3 pluses, we have 4 sames or 0, we have 0 minus. And we we assess the concept B, C until G the same way when we will calculate all the plus the same and the minuses, and then we make a rank. So after the process we will have rank 1 until 7, then we have concept A as the first rank, concept E in the second rank, and so on and so forth, and with concept C at the 7th. So we will continue after the screening with 4 concepts, which is A, B, E, and G. The best for the 4 highest rank from the available alternatives. Okay, so now we try to think about combining and improving the concept from the 4 concepts that pass the screening process. So for example, concept D and F, it is combined into concept DF, which is lever stop, or concept G plus, which is dial screw with plus. And we try, after we have these two improved concept, which is G plus and DF, we will go into the concept scoring steps to determine the best concept. First, we prepare a selection matrix, also rate and rank the concept as well, and then combine improved concept and select one or more concepts. Okay, like for example, let's focus on one of the attributes which is ease of use. We could break down ease of use in terms of ease of injection, cleaning, and loading. And we have a scaling for rating the concepts, which is 1 much worse than the reference, 2 is worse, 3 is the same, 4 is better, and 5 is much better than the reference. So this is the scale for rating. So okay, this is the concept scoring method, in which else is the scoring or the score, which is the accumulation of R times W, which is R is the raw rating concept and W is the weight of the criterion. We will see how to do that. So here we will have 4 concepts left, which is A as a reference, DF is the combination concept, E stretching from the previous steps, and the G plus, the is improvement from G concepts. And we will have a weight for every selection criteria. Ease of handling 5%, ease of use 15%, and the higher weight is for dose measuring accuracy, which is 25%. Okay, we will have rating here, and we will have a weighted score. Okay, so in here we will calculate, or we will multiply rating and weighted score of every concept, and we will have after multiply here, multiplication of every selection criteria, we will add it up into the total score, and we will have here from these 4 available concepts, we will have DF concept as the highest with 3.45. So we will go on with DF because it has the highest score, and we will continue to develop, and we will leave out the other 3 concepts. So those are how we do the concept generation, concept selection. I hope now you can have an understanding about how we develop the product in terms of generating and selecting the concepts as part of new product development process. Thank you for your attention. We will have a quiz here to test your understanding, and I will upload it in the classroom for you to for you to do the quiz. Okay, thank you very much again, and good luck with your final exam next week. Thank you very much.